By the late 19th century, electricity was no longer a complete mystery. Scientists like Michael Faraday had shown us the invisible fields of force that governed its behavior. We could build generators to produce energy, and we could send that energy down wires to do work. But there was a catch, a big one. The power we created was strangely fragile, almost delicate. It felt like something we had to force through metal, something that fought us every step of the way. The early electrical world was dominated by direct current, or DC. Imagine it like a one-way street. Energy flowed in a single direction, but it did so slowly and incredibly inefficiently. The biggest problem with DC was distance. The farther you sent the electricity, the more of it simply vanished. It was lost as heat dissipated into the wires. Resistance, the natural opposition to the flow of current, acted like a constant brake, weakening the power with every inch it traveled. So, you could light up a city block, maybe a small neighborhood, but you couldn't power a whole city from one central plant. You needed a generator on every corner, which was expensive and impractical. Power existed, but it couldn't spread. It was trapped, constrained. At the same time, the world was exploding. Cities grew taller, factories expanded, and the demand for energy was insatiable. The electrical world had hit a wall, a fundamental limit. And then came a man who saw this limit not as a wall, but as a door. Nikola Tesla looked at the problem and saw something everyone else had missed. He didn't view electricity as a simple current being pushed through a wire. He saw it as a dynamic system, a wave, a vibration. He understood something profound that others had either ignored or failed to grasp. Energy doesn't have to move in a straight line. It could oscillate. It could reverse its direction, flowing back and forth dozens of times a second. He called it alternating current, or AC. To the established engineers of the time, this idea sounded insane, reckless even. They were used to the steady, predictable flow of DC. The thought of a current that constantly changed direction filled them with dread. They feared instability, a loss of control, a system that was inherently chaotic. They saw danger. But where they saw chaos, Tesla saw an incredible opportunity. The magic of alternating current was that it could be transformed. Using a simple device, Transformer U could easily raise or lower its voltage. You could generate power at a manageable voltage, then step it up to an extremely high voltage for transmission. Why was this so important? Because at high voltage, you could send electricity over vast distances with incredibly low losses. The resistance that had crippled DC systems became almost negligible. Then, at the destination, you could step it down again to a safe, usable voltage for homes and businesses. Suddenly, electricity was no longer a prisoner of its own source. It could be unleashed. You could build one massive, efficient power plant and send its energy hundreds of miles in every direction. Tesla's vision was of a world where energy moved freely, where power wasn't confined to a single generator room, and where distance was no longer an obstacle. This wasn't just a small improvement on the existing system. It was a complete reinvention of what electrical power could be. Naturally, this terrified the people who had built their fortunes on the old way. The established powers had invested millions in direct current technology. Their entire business model was based on selling small, localized power systems. Tesla's AC wasn't just a new product, it was a threat to their very existence. The conflict that erupted wasn't just a technical debate between engineers. It became known as the War of the Currents, and it was a deeply ideological battle. It was a fight between control and freedom. It was centralized limitation versus distributed power. It was the old guard clinging to a system they could manage versus a visionary pushing for a world of limitless possibility. The supporters of DC, most notably Thomas Edison, launched a vicious campaign to discredit AC. They tried to paint it as dangerous and deadly, staging public demonstrations where they used high-voltage AC to electrocute animals. They wanted to scare the public into believing that this new form of electricity was a menace that would bring death and destruction into their homes. It was a campaign of fear aimed at protecting a financial empire. But Tesla wasn't interested in building an empire or dominating a market. He was driven by a different impulse entirely. He was interested in what was possible. He saw a future where energy was abundant, cheap, and accessible to everyone, everywhere. He saw a connected world, powered by a system that mirrored the natural rhythms of the universe. And as history shows, Possibility is a force that doesn't negotiate gently. It doesn't ask for permission. It simply arrives and changes everything. The world we live in today is a testament to Tesla's vision. Every time you flip a switch, you're plugging into a global AC grid that he imagined over a century ago. Power plants hundreds of miles away send energy cascading across continents, all because he dared to think differently. He saw the world not just as it was, but as it could be. He understood that true progress often requires abandoning the comfortable and familiar in favor of the bold and revolutionary. The story of a C and DC is more than just a chapter in the history of technology. It's a powerful reminder that the greatest breakthroughs often come from those who refuse to accept the limits of their time. The first electrical systems, based on direct current, or DC, were incredibly inefficient. Power couldn't travel far without losing most of its energy. Imagine needing a power plant in every neighborhood just to keep the lights on. That was the reality. Cities were tethered to their generators, and the dream of widespread, affordable electricity seemed just that, a dream. This limitation was a massive roadblock. It meant that factories had to be built right next to power sources. The growth of cities was constrained. The world was hungry for energy, but it was stuck in a cage. Then, Nikola Tesla stepped onto the scene with an idea so radical it would change everything: alternating current, or AC. Unlike direct current, which flows in one direction, alternating current constantly reverses its direction. This seemingly simple change was the key to unlocking electricity's true potential. Tesla designed a complete system around it: generators to create AC power, transformers to change its voltage, and motors to use it. This wasn't just an improvement, it was a total reimagining of how we use energy. The genius of AC was its flexibility. With transformers, you could ramp up the voltage to incredibly high levels. At high voltage, electricity could travel hundreds, even thousands of miles through transmission lines with very little energy loss. Then, at its destination, another transformer would step the voltage back down to a safe, usable level for homes and businesses. Suddenly, the chains were broken. Power no longer had to be generated where it was used. This was a game changer. Mighty waterfalls in remote mountains could be harnessed to power cities far away. The iconic Niagara Falls power plant, the first of its kind, was a testament to Tesla's vision. It became a symbol of a new era where nature's power could be delivered directly to our doorsteps. Energy sources that were once considered too distant or impractical were now viable. Electricity was no longer a local affair. It was becoming a global network. The impact was immediate and profound. The modern electrical grid, the vast web of power lines that crisscrosses our planet, was born from Tesla's insight. Cities could now expand outwards, growing and sprawling without being anchored to a power plant. Factories could be built wherever they were needed, not just where power was available. This fueled the second industrial revolution, powering new machines, new industries, and a new way of life. Tesla didn't just solve a technical problem of efficiency. He removed a fundamental boundary on human progress. He gave energy freedom, but Tesla's vision went far beyond just lighting up cities. He saw electricity not only as a source of power, but as a medium for transmitting information. He dreamed of a world connected wirelessly, where signals, data, and even energy itself could be broadcast through the air. He envisioned remote communication, robotics, and a global information network long before the internet was even a whisper of an idea. His experiments with wireless transmission were ambitious, to say the least. His Wardenclyffe Tower on Long Island was meant to be the first step in a worldwide wireless system providing free energy and communication to everyone on the planet. He was a man thinking a century ahead of his time. Many of his more radical ideas were misunderstood, dismissed as science fiction, or simply failed due to a lack of funding and support. He was a brilliant mind, but also a showman, and sometimes his grand pronouncements were seen as the ramblings of a mad scientist rather than the predictions of a visionary. Despite the setbacks and the projects that never came to fruition, the foundation Tesla laid was unbreakable. The principles of his alternating current system are still the backbone of our electrical world. Every time you plug something into a wall socket, you are tapping into a system that follows Tesla's logic. Every power transformer on every utility pole is a direct descendant of his design. The very structure of our civilization are illuminated cities. our automated factories, our digital lives, depends on the freedom he gave to electricity. Before Tesla, the scientist Michael Faraday had revealed the existence of invisible fields of force, the fundamental principles of electromagnetism. He showed us the power was there, but it was Tesla who figured out how to unleash it, how to tame it, and how to distribute it on a massive scale. He took energy from a scientific curiosity and turned it into the lifeblood of the modern world. Think about it. We don't just use electricity anymore, we depend on its freedom, the freedom to travel vast distances, to change its form from high to low voltage, and to arrive precisely where it's needed, whenever it's needed. When Tesla removed the restraints on energy, he didn't just change technology, he reshaped civilization itself. Light stayed on through the night, transforming our relationship with time. Machines spread, amplifying human labor beyond what was ever thought possible. Cities awakened, buzzing with a new kind of energy, 24/7. The age of unleashed energy that Nikola Tesla began has never ended. It continues to evolve, powering new innovations and connecting us in ways he could only dream of. His story is a powerful reminder that sometimes the greatest innovations aren't about inventing something new, but about freeing the potential of what already exists. He didn't invent energy, but by setting it free, he gave us the modern world. Thanks so much for watching. If you found this journey into the history of electricity as fascinating as I did, don't forget to like this video and subscribe for more stories about the minds that shaped our world. See you in the next one.